Hello, my name is Bryan Olstad, and I'm going to be talking about motorcycle fuel injection. So now, history of fuel delivery systems on motorcycles starts with, of course, the first motorcycles being built in late 19th century. They were built with carburetors because that was the only fuel delivery system at the time. Now, various vehicles such as cars and trucks have contributed to carburetors throughout the years, all the way up until them being phased out on most vehicles today. The first fuel-injected motorcycle appeared in the early 1980s, which, for being first of its kind, as with anything, mainly it was kind of clunky and hard to deal with. But with cars and trucks starting the transition to fuel injection, motorcycles did soon start to follow that same trend, going into the 90s and early 2000s. So now, for starting with the carbureted system, some benefits are simple assembly of parts. They're mechanically operated, easy to change for the needs of the rider. Say if the rider needs, or if the rider wants to put a different exhaust on there, then that would lean out the air-fuel mixture, which this is easily accommodated for with just a bigger jet inside of the carburetor. There's also minimal electronics that deal with the fuel delivery system. Disadvantages are complex passageways within the carburetor body, which could be small little openings for air and fuel to go through. They're not as fuel efficient as fuel injection. The amount of fuel delivered is varied solely on the throttle input and not based on electronic sensors telling the computer what to do. So now, they are hard to use with catalytic converters because the fact that catalytic converters don't deal well with unburnt fuel in the exhaust because they can clog it up, and the way for carburetors don't really have a way to know if the unburnt fuel is going into the exhaust or not. So I'm looking at a basic carburetor here. You have the inlet on the left side and outlet on the right. Outlet is going to be the one right up next to the engine here, as with this picture. So now this central horizontal part, that is the airflow in there. And this top part is the diaphragm, which controls how much air goes past here. This bottom part is the fuel bowl, which contains the fuel and lets the fuel go in there. And this plate right here is the throttle plate. That thing is controlled by the throttle on the handlebars. Now, as the air goes in, it's going to pass through this venturi here at a higher velocity and mixes the fuel better, which then kind of atomizes it. It goes through here, passes the throttle plate, and then into the engine. Now, for fuel-injected systems, benefits are that they're electronically monitored with various sensors. They're a sealed system because of the fact that it's pressurized. They have a variable air-to-fuel mixture, so at lower loads, say cruising on a highway, the air-fuel mixture would be leaned out, having less fuel in there, which means reduced power, but there's no need for all the power at that state. And the use of catalytic converters is more relevant on fuel-injected systems because of the fact that there's sensors throughout the engine and exhaust and intake, which will lower the fact that there's unburnt fuels in the exhaust, which would clog up the catalytic converter. Some disadvantages, though, are they require a greater power source because of all the sensors that need to be ran, which then in turn means more power production from the generator system, alternator generator. So now multiple systems do run the system, so which if one goes bad, it could throw off the whole system. They're not easily modifiable. They do require a trained technician with the right computers and tools to modify it. So I'm looking at a diagram of one. You have air intake. This is showing the whole engine here, but the air intake right here, all this is just the throttle plate and then the fuel injector right here. So air goes in, fuel is injected, combusting the engine, goes through the exhaust. Now the fuel is pressurized by a fuel pump in the fuel tank, then is sent through a line to the fuel injector. And then this sensor on the throttle plate is a throttle position sensor, so if once the throttle is opened, the computer will tell the fuel injector to put more fuel in the engine, which then increases the engine speed. So once it goes through here, it goes through these oxygen sensors in the exhaust, which these will read what the exhaust is composed of and can adjust the air-fuel mixture, because if there's, like I said, the unburned fuel in the exhaust, which can clog up the catalytic converter, it'll adjust for that. And then, in conclusion, motorcycles have really phased out carburetors. The only ones used today, or the only ones produced today, maybe like two-stroke motorcycles, such as lightweight dirt bikes and everything, but those are also going to fuel injection now. But the only thing left is really small lawn and garden equipment that are still produced carburetors, such as lawnmowers and chainsaws and everything. But those will also soon be phased out, and fuel injection will be brought to those systems as well.